Hello everyone. In this video and in our subsequent videos, we will solve some of the numerical problems related to where we can use this normal distribution, right? So the very first question in normal distribution, it is read as the lifetime of a certain type of battery has a mean life of 400 hours with a standard deviation of 50 hours. So this is we can say 400 hours is our mu because that is the mean, and then standard deviation of 50 hours, this is our sigma. Means 400 is mu and 50 is your sigma. Assuming the normality of the distribution of lifetime means the life of the batteries follows a normal distribution. That is the meaning of assuming the normality of the distribution of lifetime. So what are to be found? What is to be find? Number one, the percentage of batteries which have lifetime of more than 350 hours, means greater than 350 hours. That is first question. Then find the lifetime value above which the best 25% of the batteries will have their time. Third question, the proportion of the batteries which have lifetime between 300 and 500 hours. So let's proceed solving this question in the next slide. I'll move to the next slide. So first of all, let us assume a random variable. Let capital X equal to a random variable denoting the lifetime of batteries. Okay. Now the question says that X is following a normal distribution with some mu and the variance sigma square, where we already know mu is given in the question as 400 hours and the standard deviation is given as 50 hours. Right. Now, let us go to the first question. First question is asking you to find the percentage of batteries which have lifetime of greater than 350 hours. If I have to find the percentage, I can very well find out the probability. And finally, after finding the probability, I can multiply that with 100 to express the answer in percentage, in terms of percentage. So let me first do this first question. So what is the question? Lifetime greater than 350 hours. So probability of X greater than, X is nothing but lifetime. That is what our assumption is, right? Greater than 350. Now here what I will do, I will also define, already we spoke in the previous video about converting the random variable, normal distribution random variable X to a standard normal variate Z. And that conversion is Z equal to X minus mu by sigma. Then once I do this conversion, I can say this Z is following a normal distribution with the mean 0 and variance 1. So what we will do now, we will subtract both sides by mu and then divide both sides by sigma. Now I can write this X minus mu by sigma as Z, and here 350, and we know mu is known to be 400 and sigma is known to be 50. So this can be written as probability of Z greater than. If you look into this, this is actually 350 minus 400 is minus 50. Minus 50 by 50 is minus 1. Now, if I have to express this in the form of a graph, how do I do it? I'll have to draw a standard normal curve. It will be a bell shaped again. This will be negative infinity. This will be positive infinity. Since it is a standard normal curve, instead of x-axis, we call this as z-axis. This is nothing but z-axis. And the center point will become 0. Now this is -1. Here we have -1. -1 should come prior to 0. So I will write -1 somewhere here. Now it is saying z is greater than -1. That means this entire area we are interested in. Means the area completely after -1 because it is greater than -1. So let me just shade that area. Right. Now, it is actually, I can again rewrite this as probability of, it is actually negative infinity to, sorry, -1 to positive infinity. So I can write it as -1 less than z less than infinity. Again, I can split this, means instead of considering negative infinity to, sorry, -1 to negative infinity, positive infinity, I can split it as -1 to 0 and then 0 to infinity. So I can write this as -1 less than z less than or equal to 0 plus probability of 0 less than z less than infinity. So either I put a equality sign here or I put a equality sign here. Any one place I will put it. Either I can put it here or I can put it here. Then in that case, other place I should not put that equality sign. So that it has got some sort of a meaning, right? Now, we had already seen that normal distribution or normal curve is symmetric on both sides. Means whatever is the area, -1 to 0, will be the same as 0 to +1. So I can write this probability as probability of, instead of writing -1 to 0, I will write 0 less than z less than, here I will put an equality because there is an equality there, 1. I can write that. Then what is this? This is actually half of the curve, 0 to infinity. So the area will, we already had seen that area is 0.5 in the theory in the previous video. So this I will write it as 0.5 because it is exactly the half of the area. Now, for this probability of 0 less than or equal to z less than 1, we will use the table, right? So what I will do, how the table will look like, I will just stop sharing this screen and I will share a different screen. The tables I will show you from where we can get that value. Means I need to look for 0 to 1. Means for a value z equal to 1, what is the probability? We'll see that. Yes, now this is our table. Let us just see the z value is here. We are interested in finding out the probability for z is equal to 1. Z is equal to 1 here, 1.0, and there is no further decimal points. So I have to look into only 0 only, 1.00. The second digit is available here. Second digit is 0 only. So 1.00, you know, here it is written as, let me just zoom it. Here it is 0.3413. 0.3413. So this is the table what I was talking about. It is called as what do you call, area under standard. This table is called as area under standard normal distribution from its mean. Here the mean is 0 only. So 0 to any value we can able to find from this table. So we already saw for 1 z is equal to 1 means the area or the probability will be 0.3413. So let me stop sharing the screen, go back to our slides. Sorry. Yeah. So here for the first probability, I will write it as 0.3413. which we obtained it from the table, plus 0.5, which is here already. So if I add these two, we will get 0.8413. Therefore, for this question, what is the question? The percentage of batteries of for which have lifetime greater than 350 hours, 350 hours will be, I will just multiply this by 100, so I will have 84.13%. That is the first part of this particular question. I mean question A. Now let us go back to question B. What is question B? The lifetime value above which, that lifetime in hours is unknown. It is something above which the best 25% of the batteries will have their time. So we need to find out what is that lifetime. So that is the second question. So that means what? We have to identify, I mean, we know the probability, but we don't know this X, right? So that we don't know that X value. So we will call that as something like C. We have to find out what is this C, but this is 25%. That is what is specified in the question. Means the lifetime value above which the best 25% of the batteries will have their time. So it means that X larger than some unknown number is 25%. Now again, the same logic, we will be, we will be subtracting both sides by mu and dividing both sides by sigma. Greater than C minus mu by sigma, and that is equal to, I'm sorry, what is said in that? 25% it is said. I need not write this percentage here. 25% only is 0.25. Sorry. Yeah. So I am just writing it in terms of decimals. So 0.25. So that means what? The probability is known. We have to identify what is the C value. This is known to be 0.25. Now let us consider small z equal to C minus mu by sigma. We know mu is what? We had already seen mu is 400, sigma is 50. Mu is 400 and sigma is 50. So consider this as z. So what I will do now, I will rewrite this probability as probability of, this is z. We know that x minus mu by sigma is z, greater than small z is equal to 0.25, right? So now we need to identify what is that z value. What is that small z? Now, how do we express this in terms of a graph? Again, standard normal curve, symmetric on both sides. Now, the z greater than some particular value is only 0.25. Means I have to shade it above that z value, but that coverage should be only 0.25. Means I should do it like this, because we are going to shade it above this particular value, and that should contribute only 20%, 25%. So this may be only 25%, because, for example, negative infinity to 0 is 50%. 0 to positive infinity is again 50%. Now I am choosing only half of it. So that is actually 25% only. So here let me put that z. Right now, I am interested in, actually I can rewrite this as probability of small z less than capital Z less than infinity. That is what it is, right? Z to infinity means that Z, capital Z, is lying between small z and infinity. That is equal to 0.25. Now, if I have to find this area, I may not be able to directly get it, because the table, whatever we had seen previously, that table value will give for any z value from 0 to a particular z value, 0 to some positive value, not for any value in between or any negative value, etc. So we need to convert our probability accordingly. Means I can't directly find out from the tables from z to infinity, but I can convert it from 0 to infinity minus 0 to z. Because 0 to some value, I can able to get it from the tables. Means the small z to infinity is the same as 0 to infinity minus 0 to z. That is what we are going to do. I believe we will rewrite it as probability of 0 less than or equal to z less than infinity minus probability of 0 less than capital Z less than small z. This should give me 0.25. That's what it is, right? Now, what is this? This we know it is 50%, 0.5. Bring this 0.25 this side, so it becomes negative 0.25. Take this particular probability to the right hand side, it becomes probability of 0 less than capital Z less than small z. This will become now 0.25 is equal to probability of 0 less than z less than small z. Now we have a probability. We need to identify what will be this z value. Again, we will depend upon the tables, right? So table we have to look for probability which will be there in the body of the table, and the corresponding z value is what? That is what we will be looking for. So you may not get exactly a probability of 0.25, but at least we will get a number before 0.25 and a number after 0.25. Let us see how we can see from the tables. We will be focusing on where this 0.25 is occurring. Let me share again that tables. Yeah. So now we have to look for 0.25, right? 0.25. Here it is. 0.2486, you may notice here. For 0.24886, what is the Z value? It is 0.6 and then second digit is 7. So 0.67, it is for 0.2486. And then for 0.2517, it is 0.68. Means we have two Z values. One is 0.67. For that, the probability is 0.2486. And then for 0.68, we have the probability as 0.2517. So let's remember this. One is 0.67, and for that it is 0.2486, and then 0.68, for that the probability is 0.2517. Now let me stop sharing this screen, go back to our slide screen. Yeah. So what we had seen is for a probability of 0.2486, we identified the Z value as 0.67, and for a probability of 0.2517, we identified the Z value as 0.68. So if I take an average of this 0.2486 and 0.2517, approximately we will get it as 0.25. So that means I'm adding these two values, that is 0.2486 plus 0.2517, and then dividing it by the result. I'm dividing it by 2, and the approximate average value will be 0.25. That means the corresponding Z value will also be average of these two, that is 0.67 and 0.68, which will be 0.675. That means from tables, I can say from Z tables, we can either call it as Z tables, or we can also call it as standard normal tables, or we can call it as area under standard normal distribution. Z tables is simple words, so I'm using that. From Z tables, we have small z is equal to 0.675. Now what is small z? Here it is. I can put that as 0.675. So now what will be C then? C will be cross multiplication of 6.675 into 50, multiply that, and then add 400. So we need to do that. How much do we get? 0.675 multiplied by 50. The result, I add 400. So we get 433.75 hours. So that is what is our desired answer, required answer. Oh, what is that? What is that C value? That C value is nothing but 433.75 hours. Now let us go back to the question C. There is one more question. The proportion of batteries which have lifetime between 300 and 500 hours. Proportion also can be said as probability. It's also probability. So we need to find out the probability that X lies between 300 and 500. Let's do that. Sorry, let me, this is anyway A, this is B. Now proceed to C. We are supposed to find probability of X lying between 300 and 500. That is what we have to find. Again, same logic, subtract both sides by mu. All the sides, here, here, and here. Means 3 places we are subtracting by mu, and then all the 3 places we are dividing it by sigma, so that we can substitute that conversion factor Z. So 300 minus mu, we had already seen mu is 400 and sigma is 50 less than Z. This we know it is Z. X minus mu by sigma is nothing but Z factor minus 500 minus 400 divided by 50. So what is that? This is probability of 300 minus 400 is negative 100. Negative 100 by 50 is minus 2, less than Z, less than 100 by 50 is again 2. So the graph will be like this. The center value is 0. We are interested in this area. Let me put it as negative 2. This as positive 2. We are interested in this particular area, wherever negative 2 and 2 is there. So how do I split it? I can very well split it as probability of negative 2 to 0. So negative 2 less than Z, less than or equal to 0, plus probability of 0 less than Z, less than positive 2. Again, we know normal distribution is symmetric and on both sides, which means the area from negative 2 to 0 will be the same as 0 to 2. So I can rewrite this as 0 to 2. And this is again 0 to 2. Only difference is when one has got an equality sign, one has do not have an equality sign. Means I'm talking about this. Here we have an equality sign, here we don't have. That doesn't matter. We have to simply go for what is the area if Z value is 2. Again, we will be using the same tables. I'm not going there. You can check at your end with the table, with the tables. Tables can be downloaded from internet. You can just type that wordings, area under standard normal distribution. You will get your tables. You can have a copy of the tables with you, which will be useful in so many areas because it is getting used. So for Z equal to 2, the probability value from the tables, what you will, this I will write it as 2 times probability of 0 less than Z less than 2, because it is appearing twice. And this value, I can get it from table as 0.47. So if you multiply that, you will get 0.9544. So that is the proportion or the probability for that particular question. That's all about this question. We will again meet in our next video with a new question, again in continuation of normal distribution only. In case if you find this video to be useful, I request you to please like, share, and subscribe to my channel to get regular updates of my videos. Thanks a lot. See you.